Hey everyone, welcome back to the series on how to use Git for vibe coders and how it can make you a better vibe coder. Last time we worked on building a to-do application and we made some Git commits, which are basically milestones that we can use to go back in time. So those are like save points in our code base that we can go back to, and we can also see the changes that were made for each commit. This time we are going to work on undoing some of those changes. So here, we're going to explore a couple of different topics. We're going to explore how to undo changes, revert, and reset mistakes. We're going to also learn how to use branches to isolate long sets of changes that we're about to make. For example, you built a whole app and now you want people to be able to set up a membership for the app and pay a monthly fee and start monetizing your app. This is a big set of changes that you're going to be doing to the app. You don't want that code to pollute the app that you've already built. So you're going to be doing all of that in a branch. We're going to look at GitHub a little bit. If you want to push your repository online, which usually is a good idea, you can keep it private or public. One of the main benefits, for example, is backing up your repository. If your laptop gets stolen or something happens, you spill water on your laptop and you lose everything burns and your hard disk burns and you lose all your files, well, at least you have a backup online in GitHub where you can just get your new laptop and get your repository back. And we're going to look at how to push and pull changes from our machine to the GitHub repository. All right. So let's talk about, I don't want to start with branches, even though that's how I set up my slides. I want to start with reset and revert. So let's go check that out. So here we are going to look at two different commands. Two different ways of undoing mistakes. We have git reset and we have git revert, and those work in two different ways. You can use git reset to undo all the changes that you've made that you have not committed yet. And you can use git revert to undo a commit. You don't like the commit that you've just made, you can just undo it and it will create a new commit that is the exact opposite of the commit you did before. So let's take a look at each of these. I created a prompt to ask Claude as an exercise to change the colors of my website and add a title to the page. Claude was a little too happy about it, wanted to make this painful to look at, made some changes, and now we can take a look at it, and it is gosh darn disgusting. Okay, it still works, but I do not like this at all. So what I want to do now is undo this, and so I will use the command git reset, or I can simply go here in my list of changes and say, you know what, this little button here, discard changes, I'm just gonna discard this file, this changes, and then discard this set of changes as well, and boom, we don't have any changes anymore, which means we're back to the previous commit. And now our colors are back to what they were. Now reset, it got rid of everything. Like, we cannot go back to these colors. Now I have to reprompt Claude to get back to these colors, or maybe Claude will even choose new colors, right? So you kind of have to be careful with that, because you might lose a little bit more than what you anticipated, especially if you had a lot of changes. For example, maybe I like the title change, right? So let's go back to Claude. And I'm going to say, let's do the same thing. Exact same thing. Round 2, let's make it even worse. Okay, let's see it. Challenge accepted. Truly revolting. Let's see it. Yeah, that is worse. Slightly worse. So we're going to commit our changes, our bad colors. So let's add this here, let's stage this file as well, and then let's commit this and say super bad colors selected, and commit that. I want to undo this commit. Okay, so what I can do, I'll go find the commit bad colors selected, If this is the last commit we've done, in Visual Studio Code, you can click on this little action button over here, go to your commits, and then select undo the last commit, and that will remove the last commit. So let's do that. Undo last commit, boom. Visual Studio Code undid the commit, and it basically put those files here as staged. The commit was undone, but the changes are still there. And what Visual Studio Code did with Git over here is that it kept the changes but removed the commit. So now we have those two changes over here that we can then simply discard. This one and this one. I've unstaged the changes, and now I'm going to discard them. All right, now that it's discarded, we're back to normal. Let's say, however, that now I want to undo a commit that is in the past and it's not the last commit. But let's say it's this commit here where I change my Cloud Code settings and I want to undo that commit. I cannot do this within Visual Studio Code, and so I have to find another way. And the way to do that is this little ID for each commit. So you remember in the previous lessons when we were doing the git log, actually let me show you the git log again. Git log. Every commit has this kind of really long commit ID. And that commit ID is what we're going to use to undo an existing commit that is not the last one. So in this case, it is Claude setting files are updated. I want to undo that. So I'm going to copy this. I can copy it here, or I can copy it right here. Now note that this number here is a lot shorter than the one over here. That's fine. 99% of the time, using the short commit ID will be the same as using the long one because it's unique enough. Okay, if you want to really ensure that it's fully unique, then you can use the whole number, but the short one usually is sufficient. And we're gonna undo that commit. So in order to do that, as shown over here, we're gonna use git revert and then the commit number. So let's do this. Git revert, and then I'm gonna paste this commit number. And then it's asking me for a new git message. Okay, and I'm gonna accept that one. You can probably do this in Claude as well. Git revert, git commit number, and Claude will do that for you. So now if we go back and we look here, I have this commit where I changed my settings. So I removed this line, git-c, and it was replaced with git-c, comma, and a new line underneath. Now, if we look at the latest commit, it removed those two lines and replaces them with just the git-c line over here. So it's a perfect opposite of the commit that I wanted to revert. Essentially, when those commits are all taken together, it's like the change is gone. All right, so just to go back over this again, git reset is what you use to undo the changes that have not been committed. You can do that on the command line by typing this command exactly as is, or you can do this in the Git tab on Visual Studio Code, or your editor of choice will have something similar, where if I make some changes, blah, blah, and I save those changes, I can revert by clicking this discard change little button here, and all my bad stuff is gone. Okay, so if the AI did something that you're not happy with, instead of committing, just revert all the changes. And then we also saw how to revert a specific commit. There's two ways to do that. So in Visual Studio Code, you can revert the last commit by clicking this little action button here, selecting commit, undo last commit. And then basically the changes still exist, but you have to unstage them and reset them yourself. And if it's a different commit, then you need to go get the ID of the commit over here and undo it. So now let's talk about branches. Hey guys, Louis from the future here. I was not happy with the footage I had about Git branches, and so I thought I'd come back in here and give you guys some better content So Git branches, a super important concept that everybody needs to know about. It allows you to create parallel universes in your applications where each commit in one branch will not affect the commits of a different branch. In fact, they're completely isolated in two different branches. They don't know about each other, and it allows you or your AI agents to build different tracks of commits, different sets of functionality that don't pollute the other branch. So far in our project, we've had the main branch and we've put all our commits in that main branch. Now what we're gonna explore is creating a parallel universe, a new branch where we're gonna put our commits into. And we are going to travel between these two branches and see how they don't affect each other. So this here on the screen is a way to visualize Git branches. You remember in the previous slide, in the previous lesson, we had that green line and those green circles representing commits. And those commits are done on the main branch. In this slide, we're going to be creating a new branch colored orange, and we're going to put a few commits in that branch. So the history of our application, if you look at the main branch, started with this commit over here, followed by this commit over here. Then a branch was created. In this branch, which is similar to a parallel universe, new commits were added to the branch. But at the same time, somebody else, an AI agent, whoever it might be, added new commits to the main branch and continued working on the main branch. Back in our feature branch, in the parallel universe, we finished development of some functionality and we are happy with it. We want to merge it back into the main branch. And when we merge it back, it creates one commit that is basically all the changes made in the feature branch. And then we can continue working on the feature branch. Once the feature branch is done, we can delete it because we don't need it anymore. If we're not happy with the feature branch, we don't have to merge it back. We can simply delete it and pretend it never existed. When would you use a feature branch? When you're about to make a lot of changes. You want to build a new functionality. You're not exactly sure how big it's going to be, and you want the AI to run free and make changes at the risk of making mistakes, or you're not sure that the functionality will be worthwhile, put those changes in a branch. So create the branch, switch to the branch, and let the AI use the branch. Or directly in Claude or your AI of choice, you can tell the AI to work in a Git branch. So it's always a good strategy to just start a new branch whenever you want to add some new functionality. So let's do an example of that. I asked Claude to build me an application, a tic-tac-toe game, using my favorite colors, my favorite DevJoy colors, and this is what it came up with. So it's a tic-tac-toe game. I can play as X, then as O's, and here O wins. But now I want to add a twist to the game. I'm not sure exactly if I'm going to like the result, so I don't want to add commits to the main branch that I don't need to. So I'm going to go here in Visual Studio. I'm in my Git source control tab over here, and at the bottom I can see there's this little icon with the branch name that follows it. And it shows you in the tooltip, we are in the main branch. So if we want, I'm clicking on it, and now I can create a new branch right here. So let's do that. Let's name it explosives. And it switched to the branch. You can see that down here that I'm not on the main branch anymore. If I click on this again, the same kind of dialog pops up. I can create a new branch, and I can also see my two branches that I have over here, explosives and main. You can see here there's a commit ID next to the branch, and here in the main branch there's also a commit ID, and they're the same commits, both of these. And this happens to be a commit that I made 38 minutes ago. If I go back to the slide here where I had the main branch visualized and the feature branch visualized, we're still here at the commit that I've just made last. We created the branch, but there is no commit made on the branch yet. So we're still both branches, main and explosives, are on the same commit. But let's go to Claude, and I'm going to type in something interesting like, I want a tile in my tic-tac-toe game to be explosive. When a player clicks on the tile, they automatically lose. However, the explosive tile should be invisible. Okay, let's go see how that works. Let's reload the page, and apparently now a tile should be explosive. Not this one, not this one, not this one. Oh, that was the explosive tile. This works. I am going to commit this. All right. Committed. Let's go back to Visual Studio Code, and then we see our commits. So we have the initial tic-tac-toe game. We have the color, DevJoy colors that I added. And here in our explosive branch, we added the explosive mine. So if we look at the branches now, you will see that the latest commit in the explosive branch was made now, whereas the latest commit in the main branch was made 41 minutes ago. And now we have two different IDs here for both branches, which represent the IDs of the commits made in both branches. So looking back once again at our diagram here, the main branch is still on this commit, whereas the feature branch is now on this commit. Let's switch back to the main branch. We're back in the main branch, and I can prove it by resetting the game here, and you will see that there is no explosive. I messed up. Explosive could be one of those two, but there shouldn't be any explosives. So let's try this again. And then this time I'll put an X over here, over here, over here. Oh, X wins. But you can see there is no explosives on this board because we reverted back to the main branch, and the commit that added the explosives is on the feature branch. All right. Committed. Let's go back to Visual Studio Code, and then we see our commits. So we have the initial tic-tac-toe game. We have the color, DevJoy colors that I added. And here in our explosive branch, we added the explosive mine. So if we look at the branches now, you will see that the latest commit in the explosive branch was made now, whereas the latest commit in the main branch was made 41 minutes ago. And now we have two different IDs here for both branches, which represent the IDs of the commits made in both branches. So looking back once again at our diagram here, the main branch is still on this commit, whereas the feature branch is now on this commit. Let's switch back to the main branch. We're back in the main branch, and I can prove it by resetting the game here, and you will see that there is no explosive. I messed up. Explosive could be one of those two, but there shouldn't be any explosives. So let's try this again. And then this time I'll put an X over here, over here, over here. Oh, X wins. But you can see there is no explosives on this board because we reverted back to the main branch, and the commit that added the explosives is on the feature branch. Let's say now that I want to change the colors here because I like changing colors. It's what I do for a living. Change the colors of the tic-tac-toe game to something that looks like Amazon's website. All right. Claude code is done. Let's go see what it looks like. And we have a color scheme that is closely related to Amazon. I'm going to put my X here and my O's over here. Perfect. Okay, let's commit this change. Commit this color change. And it's going to commit that to the main branch. So while it's doing this work, let's go back to our diagram. So in the feature branch, we added the explosive tiles, and then in the main branch, we added the Amazon colors. So we're here currently. So if we go back and look at Visual Studio Code, now we see that we updated the color palette to an Amazon inspired theme. If we go back to our explosives, now you see that the last commit is the explosive mines. If we go back to main, you'll see that the last commit is different. That's the color palette. So if we want to do something that's very similar to this diagram here, I should add an extra commit over here. What could it be? We could add confettis when somebody wins. So let's add that here. Before I do that, I want to make sure I'm on the feature branch, the explosive feature branch. So let's go back to it. We are on the explosive feature branch. Let's go to Claude. When someone wins the game, I want confettis to drop from the top of the screen. Claude is done. Let's go verify and win a game. Let's reload first. Remember, in our feature branch where we're in a different color palette. Oh yeah, now I have to be worried about the bombs. Okay, hey, confettis are falling. Okay, so this is good. This time I'll commit that from Visual Studio Code and save myself some tokens. We have 2 changes over here. I'm going to stage both changes. And that's it. And I'm going to say confettis added for the winner. And oops, and hit the commit button. Okay, so now we have 2 commits in our branch. Add hidden explosive mine and adding confettis. So where are we? We are here. Currently, we added this commit. Now our feature branch is done. We want to merge the results back in. Now remember, our main branch has the Amazon colors made with this commit, and our feature branch has the explosives and the confettis added as 2 commits. Both changes will exist. Both sets of changes will exist when we merge back our 2 universes together. I'm going to come and click over here, and then I'm going to select branch, and I'm going to select merge. And then it's asking me for a branch to merge, and I'm going to select the explosive branch. Now the 2 branches have been merged together, and it wants to create a commit with the name merge branch. So after we're done, like we saw in the diagram, when we merge a branch back into the main branch, it creates a new commit. And like all commits, we need to give that commit a message. And usually the message defaults to merge branch explosives, which is fine. Okay. Look at what happened over here. Now our timeline of commits looks a little bit different. We have the initial tic-tac-toe game commit that we created. We have the DevJoy colors added commit. So the first 2 commits here and here. But here Visual Studio is actually redrawing this kind of parallel universe thing. It shows you that 2 branches were created. One branch with the commit where we added the Amazon-like colors to the main branch, and then it draws this other branch here where we added the explosive mine and the confettis, and when the branch was merged back. If we look at our list of branches here, we see that we have the main branch and we see that we have the explosive branch. I can still go to the explosive branch. It still exists. The last commit on that branch is adding the confettis. However, now if I go to the main branch, the last commit is the merging of that branch. Now that branch is not very useful anymore. Well, you could keep working on it. You could keep adding commits and merging the branch over and over again if you want to do that. You could also delete it and clean up the space a little bit. It's a good habit to clean up branches and delete them when you don't think you're going to be using them anymore. Otherwise, you will be accumulating quite a list of branches and it will pollute that list. Let's delete the explosive branch, and to do that we're going to go to those little 3 dots button over here where we had the branch sub menu. This is where we merged the branches, but here we want to delete the branch and we're going to delete explosives. And now the branch is gone. It doesn't exist. All we have is the main branch. So I think that's it for right now. Back to you, Louis from the past. Okay, so now let's take a look at GitHub. GitHub is a great way to back up your code. You have all your changes and commits on your local machine. You can go back and forth in time, which is great. It's in itself a way to safeguard your code, but it's not completely safe. If you lose your laptop, if your laptop gets stolen, if you spill water on it, if you lose access to those files somehow, then you lose access to your code, so it's good to back it up. GitHub is a great way to do that. It's basically a website where you can store your Git repositories. Now, GitHub will create a new Git repository and you keep your repository on your machine and the repository on GitHub synced up. So let's go do that. I am on github.com. I'm going to create a new repository in GitHub. And I'm going to call this repository TeachGit. TeachGit. Here I can say if it's a public repository or private. I'll leave it public. That means everybody can see it. Doesn't matter, I'll delete it later. We don't need to add a README. We don't need to add a git ignore because we already have one. We don't need to add a license to our code. It doesn't matter at this point. We're just going to create it. And here Git will hold your hand and say, okay, you created this repository. Is it a new repository that you've never dealt with before, or do you have an existing repository? And in this case, we have an existing repository. So what I'm going to do is I'm going to copy paste all these commands in my Git repository on my machine. And then when we reload this page, we will see our code. Boom. So this is the code that we actually have on our machine. And it's been pushed to this GitHub repository that we just created called TeachGit. We can see our commits. Right here, we see 15 commits. So let's take a look at them. We're going to make some changes and we're going to push the changes to GitHub. So change the title to Hello GitHub. All right, commit this. So now if I do git log, I will see that my last commit is update title to Hello GitHub. Okay. If I go back to GitHub over here and I refresh the list of commits, the commit is not here. The commit is on my machine. It's not on GitHub. In order to put it on GitHub, I have to do git push. And now, if I reload this, I'll see this update app title to Hello GitHub. Okay. So now we're going to do a change on GitHub directly to simulate somebody else making a change. Let's go to source app.jsx. And here I can do some changes. Where is Hello GitHub? This is pretty small, eh? There it is right here. So I'm going to change this over here and I'm going to click to edit this file. And I'm going to do hello from GitHub. And see, I cannot save. I can only commit. And then the commit message is going to be update title. Yeah. Okay. I'm going to commit this directly into the main branch. This is not ideal. You don't want to edit files directly into GitHub and commit from there, but it is possible. So now if we go back here and look at our list of commits, I have the update title commit on GitHub. And if we go back to git log over here, we are still on the old title commit. We don't have this new commit. So in order to bring the new commit from GitHub to the machine, we will say git pull. And now if I look at the log, we have the update title commit that has been downloaded to our machine. Okay, so this is how we're gonna keep GitHub in sync. We're gonna push our changes to GitHub, and then if something has changed in the GitHub repository, we can pull the changes. Hello, this is Louis from the future again, Editor Louis. I just realized that two things happened in this segment of the video where my camera and my image of myself was blocking the text in the bottom right corner of the screen. I apologize for that. It's something I'll keep in mind from now on. And then the second thing I wanted to show you guys is that you can git pull and git push from within Visual Studio Code. So let's check this out real quick. So here in Visual Studio Code, I made a small commit just to show you guys. You can click this button here, and sync changes knows how many commits were made on GitHub and how many commits were made on your machine, and it will allow you to sync them together. It will pull the changes from GitHub and it will push your changes from your local machine. Back to Past Louis. All right, so exercise time. I want you guys now to go create a public GitHub repositories and follow the instructions to link up your repo that you created on your machine in the previous class to the GitHub repo. Then I want you to create a feature branch. So create a branch and add 3 commits to it. I want you to revert your latest commit. I want you to merge the branch back to the main branch. And I want you to push everything to GitHub and then share the link. Put in the comments below. I'll go check it out. I hope this was helpful again. Please go through with the exercises, and by the time you're done with them, maybe the next class will be done and you can watch it. So see y'all later.